The best fit as a linear model is shown below. The data points were estimated from the graph and entered in a calculator. The linear regression was calculated and plotted along with the data points. The R-squared value, which is the correlation coefficient, suggests a strong correlation. Watch the instructional video for details on how to do this. So I'm just going to go through the process here with you. First thing I had to do was I had to estimate from the graph some values. And I entered them in the calculator already. Let me go to Stat and then 1 for Edit. This is where you enter your data. And I'll just show you what I put. I mean, you can estimate your own values. It'd actually be interesting if you estimate your own and then compare with the functions that I get and see how close they are. So for 1, I got 18, 2, 14, 3, 10.3, 4, 7.9, 5, 6.8, 6 was 6, 7, 5.2, 8, 4.3, 9, 3.8, 10, 3.2, 11, 3.1, 12, 2.8, 13, 2.7, 14, 2.5, and that was it. I'm going to quit out of there, second quit. Now I'm going to show you how to calculate a linear model. I'm going to go to Stat and then Calc, so write 1. Then I want the linear regression, which is option 4. So I'm going to press 4, and then I'm just going to do Enter. And there you can see my linear regression. Okay, so I see a y, and then an a and a b. So here's my function right here, but I want the diagnostic, so I'm going to show you how to turn that on. I'm going to go to Mode, then hit the down arrow. Stat diagnostic, I'm going to turn that on, and that'll show me the correlation coefficient. Okay, let's try that again. Stat, Calc, option 4 for linear regression, and then it just has the X and Y list options, and I'm just going to go down and calculate that. Your calculator may not have this as an option, and that's okay. Here's linear regression. You have y equals ax plus b. The a value, which is the slope, is negative 0.99, and the b is 13.9, and the r squared value is 0.787, and that suggests a strong linear correlation, but it's not an exact fit. But if you wanted to use a linear model, you could probably get away with it. Okay, so the next thing you want to do is you want to graph this. And what I would do simply is just write down the function, so negative 0.99x and then plus, say, 13.9, and then you would graph that. So negative 0.99x plus 13.92. And your calculator, depending on what its settings are, may find slightly different values than this. The 13.92 might be 13.94, or maybe it would be 13.8, but it should be pretty close. Okay, well, there's our function, but what about the data points? I want to show those too. So what I'm going to do is I'm going to turn on the stat plot. I want to go second. Actually, the easiest way, just click on y equals. And then if you go up, I'm going to hit plot 1, enter. That's going to turn on the stat plot. So if I hit graph, then I can see the data points and the line all together. And I'm going to change my window a little bit. Let me try to make this, oh, let's say 20. Okay, that looks nice. Now you can really see what's going on. Here you have kind of like a curve pattern here and a linear model. And you see the line fits the curve pretty well, but there's probably a better model than this. So anyway, this is how you create that model. You enter the points in the calculator, you go to Stat and then Calc, and then choose linear regression for your linear model. And then you can go through the process of putting it on the calculator, and you always want to look at the correlation coefficient and the graph. That way you can compare visually and numerically and see how your model matches your actual data.